नमस्कार विद्यार्थी मित्रांनो, शीतल कुमार भोम केमिस्ट्री या यूट्यूब चॅनलमध्ये सर्वांचं स्वागत. आज आपण हॅलोजन डेरिव्हेटिव्ह्ज या चॅप्टर मधील इलिमिनेशन रिएक्शन बद्दल माहिती पाहणार आहोत. नेहमी बोर्डाच्या परीक्षेला विचारला जाणारा प्रश्न आहे. हा प्रश्न 3 मार्काला सुद्धा विचारला जाऊ शकतो. डिफाइन इलिमिनेशन रिएक्शन अँड एक्सप्लेन इट विथ एक्झाम्पल. तर त्याच्यामध्ये 1 मार्कासाठी इलिमिनेशन रिएक्शनची डेफिनेशन आपल्याला लिहायची आहे आणि 2 मार्कासाठी एक एक्झाम्पल देणं अपेक्षित आहे. तर सुरुवातीला आपण व्हॉट इज मीन बाय इलिमिनेशन रिएक्शन्स बघूया. द रिएक्शन इन विच 2 atoms or groups are removed from adjacent carbon atoms. So this adjacent carbon atom word is very important. These carbon atoms should be adjacent. The group should not attach to the same carbon atom in a molecule to form unsaturated compound. Means here double bonded carbon-carbon double bonded compound will be formed. This is called an elimination reaction. This is for 1 mark. In this dehydrohalogenation reaction. So in this D means removal. D, see, this D means removal. Hydro means hydrogen and halogenation. Means removal of hydrogen and halogen. This is called as minus HX. Hydrogen and halogen. This is called as dehydrohalogenation. So what is this dehydrohalogenation reaction? When alkyl halide C having at least 1 beta hydrogen should be there. Means this is the main condition. Beta hydrogen should be there. What is alpha, what is beta, we will see in the next slide part. Is boiled with alcoholic solution of potassium hydroxide. So this condition is very important. Here we have to boil this with alcoholic KOH, that is alcoholic solution of potassium hydroxide. It undergoes elimination of hydrogen atom from beta and halogen atom from alpha carbon and resulting formation of alkene. This reaction is also called as beta elimination, as or it is also called as 1,2 elimination, as the halogen is attached to the alpha and hydrogen which is attached to the beta. That's why this reaction is also called as beta elimination reaction. So here we will understand what is meant by alpha, beta and gamma carbons. So X means halogen. This X is directly attached to this carbon. It is called as alpha. Means the halogen which is directly attached to the carbon, this carbon is called as alpha. Adjacent to this is beta. So clearly we can see this is beta carbon and adjacent to this is gamma carbon. If here this side, if 1 more carbon is there, for example like this, 1 more carbon is like this, this is also beta. So if the 2 betas are there, it may be beta 1 and beta 2. In the next example, we will also consider what is this example, beta 1 and beta. So I think you understand what is meant by alpha carbon, what is meant by beta carbon, and what is meant by gamma carbon. And the hydrogens which are attached to the beta carbon, it is called as beta hydrogens. Then see how the reaction takes place. This is the mechanism is given. In this is the alkyl halide. We can clearly see this green colored X which is attached to this carbon. It is called as alpha carbon, and this carbon is beta adjacent to this. So how the mechanism takes place, we can see clearly. See in this, the base, clearly it is shown. This is the base. Picks this hydrogen, electron density is shifted here, and X is removed. So we get here BH. Means in this particular example, we get here water plus X minus. X minus means this X will be removed and this KX will be prepared. X is here living group. As hydrogen and halogen is removed in this reaction, it is also called as dehydrohalogenation reaction. Already we discussed about this dehydrohalogenation reaction. Now, this one condition is given. If there are 2 or more non-equivalent beta hydrogen atoms, means already we discussed this condition. If in any molecule there are 2 or more non-equivalent beta hydrogen atoms in a halide, then this reaction gives a mixture of products. And for the identification of major and minor, one rule is applied. That rule is called as Saytzeff Rule. So before that Saytzeff Rule, we'll take one example here. 2-bromobutane. 2-bromobutane. This question many times asked for the board examination. 2-bromobutane on heating with alcoholic KOH, it gives mixture of but1-ene and but2-ene. So how this reaction takes place, we can see this is the 2-bromobutane according to the IUPAC nomenclature system. This is nearer, so we have to give the numbering. This is carbon number 1, carbon number 2, this is carbon number 3, and this is carbon number 4. On the second, carbon bromine is attached, that's why it is 2-bromobutane, and 4 carbon atoms are there. Now, see the reaction condition is same, alcoholic KOH, but what is the difference in this mechanism? In this mechanism, only one beta hydrogen is there, but in this 2-bromobutane, there are 2 betas. This is beta-1, means these 2 hydrogens are beta hydrogens, and in this there are 3 beta hydrogens. This is beta-2. So these 2, there are 2 beta hydrogens, and these 2 are non-equivalent. These are not same. So first beta-2 hydrogen is removed. Suppose, just I'm going to erase all. See, this is beta-2 hydrogen. Beta-2 hydrogen means this is beta-2. If this hydrogen and this halogen is removed, if this bromine is removed and this hydrogen, one of this hydrogen is removed, we get double bond here. We get double bond here, and we get this product, but1-ene. See, we get but1-ene product here. And the second condition, see the second condition, beta-1 hydrogen is removed, means this, if this beta-1 hydrogen means out of these 2 hydrogen, if 1 hydrogen and 1 bromine is removed, we get double bond here. We get here but2-ene. So we get 2 products here, but1-ene and but2-ene. See, so for the identification of major and minor, we have to apply here Saytzeff Rule. So what is this Saytzeff Rule? The rule is very important, and it may be asked for 1 mark. In dehydrohalogenation reactions, so this rule is applicable for dehydrohalogenation reaction. The preferred product, preferred means the major product, is that alkene, because alkene is prepared in dehydrohalogenation reaction. The preferred product is that alkene which has the greater number of alkyl groups here. So this is the Saytzeff Rule. The product which contains greater number of alkyl groups attached to the doubly bonded carbon atom. This is also very important thing. Means, see in this example, if suppose this is the carbon-carbon double bond. So here is CH2, here is CH. So no, in this but1-ene, no any CH3 group or methyl alkyl groups is attached to this carbon-carbon double bond. But here, if you see carefully, this is the carbon-carbon double bond. And here, one CH3 is attached and another CH3 is attached here. Means 2 alkyl groups are attached here. So this is the major product according to the Saytzeff Rule. It is clearly mentioned. Therefore, in the above reaction, but2-ene is the major product. जर आपल्याला हा व्हिडिओ आवडला असेल तर जरूर व्हिडिओला लाईक करा, आपल्या मित्रांना शेअर करा, चॅनलला सबस्क्राईब करा आणि आपल्या इतर मित्रांना पाठवा. धन्यवाद.